Okay, welcome back, guys. This is our last lesson of this unit. In this lesson, we're going to learn about inverse relations and functions. Hoping to get through this pretty quickly. Last lesson, you learned about compositions of functions. And that was taking f of x and putting it inside of g of x, and taking g of x and putting it inside of f of x. Today, we're going to talk about graphs of functions to determine if they have an inverse function. And we're going to find inverse functions algebraically and graphically. New vocabulary, inverse relation. An inverse relation is just a relation that shows the opposites. So if I have a point 2, 4, the inverse of this point is going to be 4, 2. Inverse function. You can have inverse relations that are not functions. We're only going to be concerned with inverse functions today. 1 to 1. A function that is 1 to 1, we know for a fact has an inverse function. So let's talk about the horizontal line test. You guys should remember the vertical line test. The vertical line test determined if some relationship was a function. This time, the horizontal line test shows that if I have some function, in this case the blue line, and I have this red horizontal line that goes along it, if I move this horizontal line up and down along this blue line, it's never going to cross more than once. If it only crosses at maximum one time, then we know that it has an inverse, and that inverse is a function. So let's see it applied. So we would use a graphing calculator to graph this function. Then we're going to apply the horizontal line test. So I graph this function. Here it is right here. And then I'm going to use a horizontal line, this red dashed line here. And what we see is that the function crosses the horizontal line in 2 spots. With it crossing in 2 spots, we can tell that this is the inverse is not a function. It may have an inverse, but the inverse is not a function. So now we're going to do the same thing. We're going to use a graphing calculator to graph this function here. And then we're going to use the horizontal line test to determine whether the inverse has a function. So I start with this function, and then I have this horizontal line. So as I move this horizontal line up and down along this function, we see that it's not going to cross more than one time. Therefore, yes, the inverse function does exist. Okay, go ahead and try this one. Hopefully you guys ended up with A. Finding the inverse of a function. So let's say I want to find what the inverse is. We're going to use these steps to do this. First thing we're going to do is we're going to determine whether the function exists by using the horizontal line test. So we would graph it on a graphing calculator and see if the inverse exists using the horizontal line test. Second step, in the equation f of x, so in our original equation, we're going to replace f of x with y and then interchange x and y. Step 3. After you interchange them, now you're going to solve this for y. Once you have it solved for y, we're going to replace y with f inverse of x. Finally, we're going to say any restrictions on the domain of this inverse. Then show the domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. So let's see this in action. So we have to determine whether f has an inverse function. Here's our function, so we have to determine if this has an inverse. If it does, they want us to find the inverse function and state any restrictions on its domain. So the first thing you're going to do is you're going to take this and you're going to check to see if this passes the horizontal line test. Here's the function. You can see that no matter what horizontal line I draw, it will only cross at a maximum of one time. It won't cross more than once, therefore the inverse does exist. So, therefore, I need to find the inverse. So they said to take f of x and change it to y. So I've got this. Now they said interchange x and y. So I'm going to take x and y and switch them around. Notice that the y took the place of both x's and the x took the place of y. Now I have to solve this for y. This should be algebra just for you guys. We know we can't do anything with this 2y in the bottom, so I have to multiply it by both sides. So I have 2y minus 1 times x equals y. Distributing the x into there, that gives me 2xy minus x equals y. Now, I'm going to move this x over here and move this y over here because I need all the y's on the same spot, same side, so I can solve for it. So 2xy minus y equals x. All I did is just add x to both sides and subtract y from both sides. Now when I look at this, I say, oh wow, I got my y's here. If I can pull them out somehow, I would have them. Oh, I know what I will do. I will factor out a y. Now, I just need to get y by itself, so I'm going to divide both sides by 2x minus 1. And I have y equals x over 2x minus 1. It's coincident. Now, the last thing I had to do was, once I had this y, I had to change it to f inverse. So, f inverse of x equals x over 2x to x minus 1. It is coincidence that this and this are the same. That doesn't happen very often. So don't just think, oh, well, I can just copy over the... It very, very, very rarely happens. Okay, so now I've got this function. Now I need to state any restrictions on the domain. So looking at this, I'm going to go back to the graph. When I look at this graph, we see that the range is going to be the domain of the inverse. The range of the original function is going to be the domain of the inverse. So when I look at this, I can see that the range for this graph is going to be from negative infinity to 1 union 1 to infinity. This right here is now the domain for f inverse of x. And likewise, the domain of this original function becomes the range for our inverse. Okay, that should only make sense. Remember when I was talking about inverse relationships? How if I had 2, 4, then the inverse point would be 4, 2. How the x values switch to the y and the y turn to the x. Well, that should hold true for domain and range. Remember, domain are your x values, range are your y values. So if they're switching places, then the range from the original will become the domain of the inverse, and the domain for the original should become the range of the inverse. Hopefully that didn't confuse you, but so now we're going to do this one. First, determine whether f has an inverse function for here's your f. If it does, find the inverse function, state the restrictions on the domain. So, looking at this, I can tell that yes, this will pass the horizontal line test. So now, therefore, I have to find the inverse. So I change that to y equals 2 square root x minus 1. Interchange x and y. X equals 2 square root y minus 1. Now solve this for y. Divide by 2, so I've got x over 2 equals square root y minus 1. Need to get rid of the square root, so I'm going to square both sides. X squared over 4 equals y minus 1. Add 1 to both sides, and I finally have x squared over 4 plus 1 equals y. Changing this to what it should be, my final answer is f inverse of x equals x squared over 4 plus 1. Now, when I look at, again, we're going to state any restrictions on the new domain. So when I'm looking at the new domain, I have to look at the old range. Well, when I'm looking at this old range, well, the only restrictions are that the range for this function was from 0, and it could be equal to 0, so that's a bracket, to infinity. So this right here is now new domain. So take a minute, try this. Hopefully you end up with C. Compositions of inverse functions. Now we're going to start using this idea that we learned about in the last lesson about compositions. Because it says two functions f and g. So I got these two functions. They are inverses if and only if f of g of x equals x and g of f of x equals x. Let's see what that means. So we're going to verify that these two are inverses of each other. So we're going to start with f of g of x. So that means I take this and put it in place of x. So that gives me 2/3 3 over 2 x minus 2 plus 2. Oh, wait, look at this. This cancels, this cancels. So now I'm just left with x minus 2 plus 2. Oh, well, that cancels, and I'm just left with x. There's the first part. Now you have to do g of f of x. So let's do that one. So this time I've got 3 over 2. And in place of x here, I put this thing. 2/3 x plus 2 minus 2. Minus 2. So then, again, we're looking at this and we see these things cancel. Woohoo, that's nice. So now I've got x plus 2 minus 2. Oh, well, those cancel too. So I'm left with just x. So I've got f of g of x equals x, g of f of x equals x. Yes, these are inverse functions, and this is our proof. This is our verification. Your turn. Try this one out. Hopefully you ended up with A. Okay, find inverse functions graphically. So now I'm going to take this function, and I want you to remember that relation, the relation said that when I was talking about inverse relations, we switch the x and y coordinates. That's what I want you to do here. You're going to find these maximum points and minimum points, and maybe some other points along here, maybe right here, and here, and here, where it crosses the x-axis and your maximum points, and these are all called what we call critical points, and we're going to switch them around. So this, let me change the color of my pen. Ink color, we'll make it blue. So if I switch this point around, this point is 0, 0, so that stays where it's at. So that doesn't move. That's still there. This point, which was -2, 0, becomes 0, negative 2. So now it's down here. This point, which was negative 1, 2, becomes 2, 1, negative 1. And then we've got this point down here, which was 1, negative 2, now becomes negative 2, 1. This point was 2, 0, so now it's going to be 0, 2. So now when I connect these points, you're not going to connect them up and down anymore. You're going to connect them like that. And there's your answer. All you're doing is switching the points. One for you to try. Remember, critical points. I would start with this critical point, maybe this one, and maybe this one right here. That would probably be a good one to switch around. And then you connect them. Hopefully you end up with A. Alright, so story problem. Let's try to go through this one really quickly. We're starting to run out of time. The fixed costs for manufacturing. Fixed costs for manufacturing one type of stereo system are $96,000 with a variable cost of $80 per unit. So automatically they're spending $96,000, and then every unit they sell is going to be another $80. The total cost for creating this is f of x of making x stereos is given by this equation. Explain why the inverse function f inverse exists. Then find f inverse of x. So immediately here's your graph. Passes the horizontal line test. So explain why the inverse function exists. It passes the horizontal line test. Now find it. So we take y equals 96,000 plus 80x. Switch the x and y around. X equals 96,000 plus 80y. Solve for y. So now I've got x minus 96,000 equals 80y. Divide by 80. And I've got y equals x minus 96,000 over 80. So then this becomes f inverse of x equals x minus 96,000 over 80. There's our answer. Okay, fixed costs, same scenario. This time, what do the inverse of x and x represent in the inverse function? So now remember, they switched places. So therefore, the whole idea of this is f of x was the total cost. So now, and x was the number of stereos. So now we're saying then that x is going to be the total cost, and f of x is going to be the number of stereos. They switch places. Okay, so now we're looking at the same scenario. What restrictions, if any, should be placed on the domain of f of x and f inverse of x? Well, let's think this through. We can't have negative stereos and negative costs, so we know that one of the restrictions is it has to be greater than 0. Now, we can't have, we're not going to create half of a unit, so we're going to have to say that they have to be whole units. So we can't, because we can't create half a unit for $40. Furthermore, the cost has to be in multiples of 80, because the cost can't be simply $96,001. It has to be $96,080 or $96,160. and that would be 2 units that created, and so on and so forth. So we would have to make sure that we explain those domain restrictions simply by just thinking this through using logic in our brain in real life. Okay, so now once we have that, find the number of stereos made if the total cost was 216,000. So if the total cost is 216,000, then we're going to say 216,000 equals 96,000 plus 80x, and then we're going to solve this for x. So subtracting 96,000 from both sides, gives me 0, 0, 0, 0, 12. 0, 0, 0, 0, yeah, equals 80x. Divide by 80, and we would come up with our x. In this case, our x is 1,500. So this means they created 1,500 radios or stereos. Does that make sense? Sure, they can make 1,500 radios. If we came up with negative 1,500, no, that doesn't make sense. That's not even in our domain. Alright, hopefully this was helpful. Hopefully you can finish up the homework, and make sure to take that quiz over the weekend. There's a quiz online. Please make sure you take it. And good luck. Thanks.